and something is missing here. Yeah, I got careless. I had my negative x cubed here, which should have been multiplied through by negative 2/3 and not negative 1/3. So I should have 2/3 here, and that should give me 2/3 here. So that now the negative 1/3, negative 2/3 takes care of the 1. That leaves me negative 1/12. Now let's look at the integral over the boundary curve. It doesn't generally work out as easily as this, but in this case the lower boundary has a property that y equals 0, so that our m function is 0 everywhere on the lower boundary, and so is our n function, so that on this boundary m of xy and n of xy are both identically equal to 0, meaning they're equal to 0 at every point on this boundary. And similarly, the same is true on C3, since x is 0 and both m and n have x as a factor. I'm going to neglect the xy notation here, just indicate that everything is 0. So the integral over C1 and the integral over C3 are both 0. Now that's not the case on C2. So we have to look at the integral for this parameterization. We have to look at the integral of m dx plus n dy for the parameterization on C2. So the integral over the region, or over the curve C2 of m dx plus n dy is equal to the integral over C2 of m being x squared, so it's x squared y dx minus 2x y squared dy. Now our parameterization, x is 1 minus t, y is t. Now using our parameterization for C2, we see that x is 1 minus t, y is t, so x squared y will be 1 minus t quantity squared times t. dx is going to be the differential of 1 minus t, which is going to be negative dt. So we get the integral of 1 minus t quantity squared times t times the differential of 1 minus t, just substituting x and y expressions as appropriate in this first part of the integral. Then we have minus 2 times 1 minus t times y squared, which is going to be t squared, times the differential of y is just y is t, so dy is dt. And now this is going to equal, and that integral goes from t equals 0 to t equals 1 because our parameterization goes from 0 to 1. And now if we expand this carefully, we're going to have 1 minus t quantity squared times t, and the differential of 1 minus t is going to be negative dt. So we're going to have let's write out the intermediate step. I have the integral from 0 to 1 of the quantity. 1 minus t quantity squared is 1 minus 2t plus t squared times t times negative dt. And then that's going to be minus 2 times 1 minus t times t squared is just going to be t squared minus t cubed dt. And this integral is going to equal, after the simplification, just the integral from 0 to 1 of t cubed minus t dt, and that's -1/4. Now this should agree with this. Green's theorem tells us that it must. The Green's theorem applies only to simply connected regions, but this is a simply connected region. The functions are all well defined and differentiable over the entire region. So something certainly has to be wrong with my algebra, either here or here. And after a closer look, I discovered that these coefficients weren't all correct. Let me correct it now. Okay, let's write this out just to be careful. Negative x squared times 1 minus x is negative x squared plus x cubed. Negative 2/3 of 1 minus x cubed is negative 2/3 of 1 minus x minus 3x plus 3x squared minus x cubed. So I have negative x squared plus x cubed minus what? 2/3 plus 2x, then minus 2x squared, and then plus 2/3 x cubed, which gives me negative x squared and negative 2x squared is negative 3x squared. X cubed and 2/3 x cubed is 5/3 x cubed. Just have the 2x term. I don't have any other x term. Remember, this is multiplied by x squared, so it's not going to give us an x. So I've got plus 2x, and I've got minus 2/3. Okay, so that's 5/3 x cubed minus 3x squared plus 2x minus 2/3. Now let's double check and make sure I did that right. Okay, I believe that's correct. Okay, replacing the integrand with the correct expansion of this expression, we get this. Integrating is very straightforward. X cubed over 4 gives us 1/4. 1/4 of 5 cubes of 5/3 is 5/12, and that shouldn't be negative. The negative is kind of left over from before. Okay, then we have x squared gives us x cubed over 3 times negative 3 gives us negative 1. Get a plus 1 integrating the 2x, a negative 2/3. So negative 1 and 1 give us 0. 5/12 minus 2/3 is 5/12 minus 8/12, which is negative 3/12, which is negative 1/4. And now we've verified Green's theorem for this simple region.